All right. Good afternoon, everyone. I hope everybody's still awake. So yeah, today I'm really excited to introduce to you HETUProtocol with this mysterious subtitle, Intersubjective Consensus Machine. Hopefully by the end of the talk, you guys have a better understanding of what we are building. Oh, okay. Oh, this particular machine got stuck.
Oh, it's a slide.
Oh, okay. There's, okay.
Oh,
That still works.
Okay, perfect.
Does
Thank
this
you.
still work? Yes, that also works.
Okay.
For some reason, mysteriously, it works again. But anyway, okay. Yeah, I think if you've been to some of the panels today, I think we have discussed some of this, the issues some of these issues that shown on the slide are already been discussed. So one of the problems existing blockchains have, I think, is the value distribution. We think is the value distribution problem, right? So we have so many contributors to our AI platforms, AI solutions, but the current value distribution model, where basically mean how people earn, and that's very monolithic, the way these blockchains rewards people. So that means this creates a problem of concentrated power. Those who are token holding whales, and for a lot of us, right? So we are at a very disadvantaged position, and because most of the decisions on blockchains are purely objective, right? So that leaves a lot of more subjective kind of value proposition. The propositions are not covered by the existing blockchain systems, right? So things like AI. Right, so things like AI. So the AI creation process is extremely complex, right? So you have a lot of contributors that throughout this process, like data and GPU clusters doing training, different kind of training processes, like fine-tuning, distillation, and inference on edge devices, so on and so forth, right? So we have all these contributions to this complex process. And these mostly happen off-chain at the moment, right? Just because, I mean, there is, you cannot really, either you don't have the resources or capabilities running on-chain, and some of these processes are really non-deterministic and sometimes subjective, so that you can't really create such a, for example, smart contract for them running on-chain. So really, there's a misaligned incentives for most contributors, right? So a lot of a lot of us actually make contributions to these AI projects, but we are not really getting the contributions. So that is a problem, and I think a lot of people are solving this problem. A lot of projects you probably seen today. So what is unique about Hetu? So Hetu views this problem and propose a fundamental solution that is based on this philosophical model called causal graph. So we believe that there is causality in like most application scenarios, right? So causality essentially means, right, if there's a causal dependency between any two events, right? So there are, for any kind of decentralized system or distributed system, so there are causal dependencies, but just most of them are inherent, right? So you are mostly not reasoning about causality in your existing infrastructures. We want to make that explicit, right? We want to actually look at the causal influence of events in a decentralized network, right? And once you look at the causality, then you can model this causality using a directly acyclic graph, or a DAG. So this DAG with vertices as the different events in your system and edges as the causal dependency. Right? As I said, it really has wide applicability beyond just simple financial applications, your AI applications, social applications, your DeSci applications, anything you can think of. You can probably think of some kind of form of causality in them. So causal graph is a really powerful abstraction, but the problem is that it's not particularly scalable, right? So you can imagine this causal graph grows indefinitely, right? So if you want to always disseminate and pass around this causal graph, that is not a particularly scalable design. The other problem is that any adversaries in an open network, they can try and want to manipulate your causal graph data. So that means they can essentially manipulate your causality in your causal graph. So how do we deal with those problems? So we have two solutions. The first is we leverage a sort of a classical solution in distributed systems called logical clock. So logical clock is a very compact representation of a causal relationship in a fully distributed system. Right? So we essentially leverage this design of logical clock, which was designed about 40 years ago at this point by Turing Award winner Leslie Lamport, to essentially reduce the cost of reasoning representing causal relationship and causal graph in a fully decentralized network. So the other part, which is our own research, is to develop security solution to ensure that causal relationship or causal graph is not manipulated by adversaries. Essentially, we designed a verifiable logical clock, or VLC, for security. So we leverage a pretty novel form of cryptographic solution using zero-knowledge proof and using TE hardware to provide this kind of security guarantees. So with our causal graph and our VLC constructs, we designed a new form of blockchain protocol. So this protocol uses a proof of causal work. So the concept is similar to proof of work, but instead of doing cryptographic puzzles to ensure security of the blockchain, we instead encourage these participants to make useful contribution to your network by extending causality or extending the causal graph. So when you extend the causal graph, basically means, for example, if you're doing AI, right? So for example, I can take your your user data, and then I can extend the causality by maybe do one iteration of the training. Someone else can take my partial result of the training process, move one step further, so that is also extending causality, right? So we treat this all as useful work of working on this causal graph, and then we can, the validators can collect many of these graph extensions, and then use the VLC as proofs and submit them to the chain. And then the chain use this proof of causal graph extension as security measure. Okay. So unlike existing blockchain, so the causal graph is a very flexible structure, right? So that means there can be many parallel graphs possible, right? So the other way of thinking them are just forks, right? So we don't discourage forks. We think that there's no absolute correct answer to which causal dependency or which causal graph is correct. So each participant or each validators can have their own notion of which graph to follow or to extend. But that seems a bit chaotic, right? So how do we resolve these different parallel graphs? So here we formalize a new form of consensus, which is very different from existing objective consensus. This is called intersubjective consensus. Because all these notions of which graph is better or worse is very subjective, right? So we let the participants, the network, the users to decide which one they want to follow, and then eventually we'll have collective agreement by the participants themselves who have the common values deciding which graph they should follow. Right? So this has the property that we will incentivize people to make impactful contributions, right? Because if you make impactful contributions and people really think that your contributions are good, then they will extend on your version of the graph, and eventually you'll get the rewards you're supposed to get. Right? So with this causal graph, we enable better value distribution as one of the key problems we address. I talk about in the first slide. Right? So causality in a causal graph essentially implies contribution. Right? So you can go back your causal graph and then basically analyze and figure out who exactly are the contributors to the final outcome. right? And as I said, intersubjective consensus incentivize impactful contributions, right? So you want to make your contribution and make sure that most of the participants in the network will follow your graph, right? And with POCW, we ensure that our chain structure is decentralized, fair, and secure. Okay, we have built a few interesting projects on top of the Hetu infrastructure. So the first one is called the Hetu Model DAO. So this is our project trying to co-build artificial intelligence. Right? So the AI models, they stem from a broad set of contributions, right? So you have your base models and many different type of base models, and then you can do fine-tuning, distillation, RLHF on these base models, or to get your fine-tuned models for a particular vertical scenario, right? Being your science scenario or any kind of other application scenarios. Right. So what we do with model DAO, right? So there's a key component is called a model graph, which tracks the model evolution process, right? So how does your final model evolve from, like, for example, the base model, how you fine tune it, and later maybe you do distillation to produce your final model. Right. So as I said, so this kind of graph representation allow us to incentivize contributions that lead to AI breakthroughs, right? So you want to have these models that many other people will follow, and then once, for example, you tokenize your model, and then we can go back and analyze the graph to understand who are all these contributors to your final success, and then we're able to attribute them properly. Right. So the goal is to co-build powerful AI based on vertical models in a fully decentralized manner. So we actually have a quick demo. So this is a small part of our model graph. So I think, sorry, might be a bit small on this big screen. Right. So you can see that there are some of these interesting models that derived from a base medical model. So the base medical model is also fine-tuned from some existing LLM models, right? And then, so from this graph itself, you can already see how these models evolved. So that once you have a very successful model, you know that this is not done in isolation, right? So this is actually contributed by a bunch of other models in the earlier stage. You can also, one interesting thing is that we do not only track the model itself, we also track in each step of the model build process who are contributing to this particular model, right? So here, hopefully you can see that there is this, we show the percentage of contribution, things like how much of contributions from the base model, how much is from the algorithmic innovation, how much is from the data set, from the builder, and from the validator, and so on and so forth. Right, so that gives you, and this is all done in a decentralized manner. All right, so there's no collusion, and then so finally, when you have a token, and then you can distribute your values in a fair and decentralized way. So that is our first project we built on top of Hetu. But causal graph, as I said, it has wide applicability. Right, so it goes even beyond just AI models. Sorry. So the other thing we are looking at is that so the success of many of these AI or Web3 projects are the result of bigger community, right? So you have your community members who either hype your projects and help bring users and then bring KOLs to your projects, right? But all these social interactions that helps the success of these projects, currently we are not really attributing our value back to this our users, right? So we developed another project called HETUverse that helps you track social contributions to a project. Okay, so instead of me showing you this, I will actually pre-record a video. So hopefully, because live demos sometimes can go wrong. So I think this is probably a bit better. Okay, so the audio is not going through the. Okay, let me see. It does have audio.
Okay, I can try.
No, it's coming from the laptop.
Okay. What happens if I turn it all the way up?
Where your meaningful social participation. So does it go through the AV system? Okay, I can see if where is this one? No. Oh, sound.
Awesome.
Okay, I still don't hear anything.
Nope.
It's okay. I can explain what's happening. Maybe. Okay, that's
Okay.
probably easier. Okay, so yeah, I guess the audio doesn't work. So
Use your microphone next to the.
okay, I can try that. So let me
Then I have to
switch back
back.
to. Okay. Welcome to HETUProtocol, where your meaningful social participation translates into real rewards. When you link your accounts and engage in meaningful activities, the system automatically verifies actions like forming real connections or contributing to valuable discussions. These actions earn you points, which are securely tied to your decentralized social ID. Social IDs are fully decentralized, tamper-proof, and completely under your control. There is no central authority. These IDs act as digital assets you own. To explore and track your decentralized identity, use HETUScan, the analytical tool that ensures complete transparency and trust. Let's search for user ID in the social graph. Here, you can see this user, Nico, is highly active on Twitter and Discord. Now, let's look at Nico's network influence. HETUScan highlights key connections, such as this green node, who brought the highest level of influence to Nico's network. HETUverse ensures fair and transparent recognition of your contributions. Unlock the value of your actions powered by trust, transparency, and decentralization. That's why you don't do live demos. Something always break. But anyway, okay, so that's HETUverse. So our the other cool project we are currently working on. So it's also already in testnet. So feel free. It's all gone online. So feel free to scan the QR code and participate and earn rewards. Okay. So let me conclude. So today's talk, I discussed the value distribution problem in traditional blockchains. And we propose one fundamental solution to this problem by reasoning about the causal relationship between different events in a decentralized network and building a causal graph that tracks these causal dependencies. And on top of this idea or philosophy of causal graph, we build a proof of causal work and intersubjective consensus in our HETUProtocol. And on top of HETUProtocol, we built two interesting projects. One is ModelDAO, which the goal is to co-build powerful AI models. And the other is HETUverse, which tracks your social contributions to projects. As A2 project, our goal is to decentralize social, AI for science, governance, and much more in the near future. And here are some the QR codes for our A2 websites, GitHub, Twitter. So if you're interested, please follow us. And I'm also happy to talk to you after the talk. All right, thanks.